Welcome everybody, also from my side. I will be taking the next few minutes, half an hour, to introduce you to our work in French Guiana. For those of you that don't know me yet, my name is Ina Sieber from Leibniz University of Hanover. I'm a lecturer and researcher at the Institute of Physical Geography and Landscape Ecology, and I will guide you through this presentation today. Unfortunately, our colleague Aurélie Dourdin from CIRAD, our local partner in French Guiana, cannot be here today to share the presentation with me, so I will be doing it instead. But time is running, so I will shortly introduce you to the case study area, the small recap on mapping ecosystem services, then we'll talk about the objectives, methodology, results, and implications for policy and decision making. At this point, I would like to thank our collaborational partners in French Guiana, the ECOSEO project, an Interreg project led by WWF and many local partners in the Guyana Shield for the collaboration on this work. Especially and Laurent Kell, thank you very much at this point. Now I will turn off the camera to make it run smoothly, but if there are any connections problems, please let me know. Today we're talking about French Guiana. French Guiana is located on the South American continent, and it is one of the, well, it is the only continental overseas region of the entire European Union, if you consider Greenland an island. We are located in French Guiana with a tropical climate close to the equator, distinct wet and dry season. We have tropical ecosystems. We have sandy beaches, rocky beaches at the coastline. We have savannas and tropical forests stretching throughout the hinterland of the country, of the territory, marked by large patches of intact forest. It's one of the last remainders of intact tropical Amazonian forest in the area. And as you can see on the picture here, we have a large diversity of tree species here. Notably, 1 hectare of French Guyanese rainforest has as many tree species as entire Europe together. We also have a large ethnic and cultural diversity in the inhabitants of the territory. We have many different tribes and indigenous communities living along the major rivers of the city, of the territory. But the large majority of the population is located in the coastal belt, in the littoral belt at the coastline. The main economic activities are not restricted to the airspace industry. We have the only European space base in Kourou at the coastline. And one other economic activity that is very present in French Guiana is related to gold mining, especially at the inland, along the major rivers. We see gold mining taking place. But we're not talking about economics, we're talking about ecosystems today. And here we've brought you a map showing the major ecosystems in the Guyanas. And as you can see, a large part of the territory, 95%, is covered with Guyanan moist forest. This Guyanan moist forest stretches through parts of Brazil and Amapá, through French Guiana, Suriname, and Guyana, and makes up the ecoregion of the Guyana Shield. In French Guiana, we also find Amazon, Orinoco, Southern Caribbean mangrove ecosystems in the north, and freckles of Guyanan highland moist forest in the hinterland. Of course, this looks as if it was one homogeneous ecosystem type, but of course we have various types of different forest species, forest ecosystems within that. But this is just for illustrational purposes, so you know that what it looks like. Now we're talking about ecosystem services in my presentation, and I've brought you a definition today, namely ecosystem services defined as the benefits people obtain from ecosystems. There is a broad body of definitions in scientific literature. However, we've chosen this one here as it puts us humans in the center, us benefiting, well, our livelihoods benefiting from ecosystems and the services they provide. And on this overview here, you see examples from the Guyana Shield, specifically, for example, forest ecosystems in the Guyana Shield have proven to supply carbon storage and sequestration or pollination and seed dispersal services. Also, the provisioning ecosystem service of materials and fibers for building, for example, timber for construction purposes, but also recreational activities, cultural ecosystem services by, for example, landscape aesthetics and scenic beauty. And here you can see other examples as well, just to give an overview of what we're talking about today. Now, the rationale for our case study, for the MOVE case study in French Guiana, was to present an overview of land use and land use changes throughout the territory, focusing on the years 2014-15 up to now. And the second part of it is to map ecosystem services bundles for different land uses within the territory. Now, the link between land use and ecosystem services is quite simple. Land use, land cover largely determines which ecosystem services are supplied, and this link has been proven multiple times. The ecosystem services that are provided or supplied by a certain land use, land cover type, short LULC, are often multiple. So we're talking about ecosystem services bundles here. And these bundles are defined as a set of associated ecosystem services that are linked to a given ecosystem and that usually appear together repeatedly in time and or space. Rotzeb, Hearn et al. Say it here, so there indeed is a link between the land use, land cover, the ecosystem, and the services that are supplied. So how can we map that? Those of you that joined me on the webinar of the ASES are familiar with this slide. We do indeed have a broad range of methods available for mapping and assessing ecosystem services. And these methods come at a different level of complexity, but also at a different ease of data acquisition. For our study in French Guiana, we've chosen a method with a simple level of complexity using lookup tables and expert knowledge. However, these methods have proven to be very sufficient if we have limited access to the field, remote conditions, to our research areas, and if we have difficulties to access data, or if we have data scarcity. So that's the rationale why we've chosen this method for our case study. Now, what it looks like in detail is shown in the flowchart here. The assessment that we've conducted is twofold. Firstly, drawing upon land use, land cover data. We've used 3 different base data sets, the CORINE, land use, land cover, deforestation data, and OpenStreetMap data, combining that with an ecosystem services assessment that has been conducted in 2019. Bringing up the information together in form of a lookup table and combining ecosystem services bundles. And I will present you the results in the next minutes. First, I would like to draw the attention on the input data sets that we have used for this study. We've started with the CORINE-based land use land cover data set for 2012. CORINE is the standardized, harmonized land use data set we're covering the entirety of the European Union. We have standardized 44 land use classes that, well, not all of them are found back throughout the EU, but the classification is the same. And it's only available though for the coastal fringe or the littoral belt in French Guiana. This is a pity as it leaves out large parts of the territory uncovered. Therefore, we've drawn upon the territorial land use land cover data set based on the year 2015 that is available on the national geodata platform GeoGuyane. It's been uploaded by Sieber et al. In 2017, and it's specific for French Guiana and the land uses. It has 15 distinct land use classes, and apologies for the screenshot here. The resolution is very high. As third data set, keeping in mind that both CORINE and the national or the territorial data set for French Guiana are based on the year 2015. This, of course, is not sufficient to assess land use changes. This gives us an information on the status back in 2015, but we need newer information. Therefore, we've drawn upon the OSM OpenStreetMap community-based dataset from 2020. OpenStreetMap is probably something that most of you are familiar with. With some background information here, it is a community-based product of georeferenced data. We've downloaded it at the GeoFabrik. It has 27 LULC classes, and the focus here is on mainly urban areas, as that is where people can actively contribute best, easiest through georeferencing, aerial pictures and such. So it's really a community-based product, but the verification, the ground truthing of this data set is still pending, as it's difficult to do that on a regular basis. Now, for deforestation data, we've drawn upon the CESBio CNS disturbance map published by Baller et al. Just this year. It's based on forest losses are determined based on Sentinel-1 imagery, and we have the information for the years 2015 to 2019. What you can see on this map is not much. It's probably a white map with 3 red cutouts here, but that is due to the small size of deforestation events. Most of them are smaller than 1 hectare. So it's not visible on a territorial map. However, if you zoom in, here we see the example of Saint-Laurent-du-Maroni on the border with Suriname. Here you can clearly see the deforestation events, the color showing the year. You see another area of Maripasola. You can clearly see that deforestation events are taking place in the outskirts of the city, in mainly for shifting cultivation, what is called abatis brûlis. And here you can see especially the deforestation events taking place in Peruanoville, at the Surinamese side of the border of the Maroni River. Then here's the example of Maturi, close to the airport of Cayenne City. And here you can also see that deforestation is not taking place so much in the urban areas, but rather in the hinterland, and where access is given once deforestation accelerates. All right, this is and land use changes. Now I'm coming to the second part of the assessment, the ecosystem services assessment that has taken place in October 2nd, 2019. Here we've hosted a participatory stakeholder workshop in Cayenne at the university campus. The workshop was led by WWF France, us, Leibniz University of Hanover, and the ECOSEO Interreg project. You see the logo of all of the partners. And on the right figure, you see Aurélie Dourdin introducing the MOVE project. On the left figure, you see Clément Villien from the WWF. What we did in this workshop is filling a so-called ecosystem services capacity matrix. On the basis of this method, it's a rather established method by now, we have land use, land cover data, delineating the land use types in an area. Then we have a defined list of ecosystem services, and these are linked so-called matrix table, a lookup table, linking each land use to a certain ecosystem service. These, each cell in the matrix is filled by, well, can be filled by different inputs, biophysical indicators. We did it with expert estimations, and experts were asked to score the capacity of a land use type to supply a distinct ecosystem service. And these supply capacity scores ranged from 0, no relevant supply, to 5, very high supply. And based on this, we can create ecosystem services supply capacity maps. In our case, we didn't put the maps in the center, but we focused on ecosystem services bundles. Here you see an example and a reading guide how these bundles look like. We did these bundles for 14 land uses and 21 ecosystem services. As you can see in the colors, we have 7 provisioning ecosystem services, such as cultivated crops of food, reared animals and their outputs, fresh water for drinking purposes, just examples. In green, you see regulating ecosystem services, for example, carbon sequestration, climate regulation, maintaining soil quality and habitat functions. And we have cultural ecosystem services. And the longer the petal of this diagram, the higher the supply capacity. We have conducted this for all 14 land uses. Here's just an overview of some of them, illustrated. As you can see in the territorial overview, we have outlined where the land use, land cover is located. And in the right part of the figure, you see the ecosystem services bundles supplied by this land use type. The codes in these maps refer to the ecosystem services that you've seen on the slide before. Now, this is quite a lot, so I would like to show you some examples. In the marine LULC, I've brought you the example of mangroves. Here you see that mangroves have an overall a balanced supply of regulating ecosystem services stipulated in green. We have rather balanced, rather weak supply of provisioning ecosystem service with PS4 ranging really high. This is wild animals and their outputs. There's fish, for example, for human consumption, and a broad array of cultural ecosystem services as stipulated in blue. Now, these bundles differ per land use type. If we look at forest, for example, we have a very strong representation of cultural ecosystem services, a very strong and balanced supply of regulating ecosystem services, and a broad range of different provisioning ecosystem services. Now, comparing the bundle of forest to, for example, urban areas, as shown in the lower right bundle, we see a stark difference. While forests have an overall very high potential to supply ecosystem services, the capacity in urban areas is quite reduced. Also, in shifting cultivation, as shown in the pie chart above, we see that the regulating ecosystem service is supplied by, well, humanly altered ecosystems are drastically reduced. We still have a strong cultural notion linked to shifting cultivation or urban areas, for example, thus it is of relevance, societal relevance, of course. But you see the overall bouquet, the patterns differ drastically. Now, what does this exercise show us? It highlights that the LULC types supply different bundles of ecosystem services, and that, as we've seen in the shifting cultivation bundle, some ecosystem services require human inputs, such as fertilizer, labor, for a strong supply of a certain service, for example, cultivated crops or food for human consumption. And we see that the more natural the ecosystem, the stronger the supply capacities for regulating ecosystem services, such as carbon storage or flood and storm protection, habitat functions, and such. But the key message here is that we can use the ecosystem services concept to highlight the multifunctionality of landscape, the different services that are supplied by a different LULC type, clearly visible in these maps, in these charts. Now, what I like to draw your attention on is the comparison of urban areas. If we use the data set from 2015, as shown in the figure to the left, we have in dark red, well, the figure shows the example of Saint-Laurent-du-Maroni for your graphical, well, for your knowledge. So we can see urban areas stipulated in red. On the left, for the land use from 2015, we've done the same thing for the OpenStreetMap data, visualizing urban areas. And on the right map, you can see data of the 2020 OSM data. And we see that there is a much bigger heterogeneous fabric in urban areas. What looks as if we have one stringent type of urban area is proven to be wrong using different data. With a different level of detail, we see that we have in the city center urban fabric dense cities, whilst in the outskirts we have gardens with patches of degraded but forest, farmland, orchards. There's a different pattern. And if we take our ecosystem services lens again, if we consider that it is one homogeneous urban fabric, we could have an ecosystem service supply that looks like this based on our assessment, based on our expert scores. Here you see the bundles for urban areas. However, if we assume that urban areas are not just urban areas, but include patches of natural vegetation and gardens and such, it might look completely different. Here would be the bundles for pasture, shifting cultivation, and urban areas. So probably for the more remote rural areas, what would be assumed to be urban could look like a combination of these three bundles for ecosystem service supply. This is really the level of detail of your land use land cover data set differs and matters. The better the information, the better we can estimate the ecosystem service supply. Now we're coming to the next step of our work. We have not only compared urban areas with the different data sets, but we've also had a look at land uses after deforestation. You've seen the deforestation maps before. Now most of it is small scale deforestation events, but here you can see the table with LULC prior to 2016, the current LULC where deforestation events have taken place, and some specifications. we see that 90% of deforestation activities that have taken place in the last years have not led to a significant land use change based on our assessed data sets. It's still degraded forest, but no significant land use change. Roughly 0.5% of deforestation activities have taken place to convert forest to agricultural land uses, farmlands, pastures, orchards, and such. Then roughly 0.5% too have converted of deforestation activities have taken place for the construction of built areas and industry, cemeteries, military, residential areas, and industrial terrain. Notably here on the bottom, you see that 3.16% of these deforestation events have taken place for the establishment of mining sites, largely modified ecosystem, but I don't want to call it ecosystem, largely modified areas where gold mining, to some extent illegal gold mining, is taking place. Now, this is, of course, nice to know. However, we need to keep in mind that the OSM data is not validated. We don't have any ground truthing taking place. It's based on community efforts to digitalize aerial pictures. So this information still needs to be verified by an updated territorial and use land cover data set that comes after 2015. But yes, that brings us directly to the uncertainties linked to the approach. Working with land use land cover data from 2015 is good. We have a very great data set there, but in our terms now, it's almost outdated. Comparing it to unverified OSM data is one way of trying to see how land uses look now, but the OSM data have their pitfalls too. They need some verification, which would take probably a long time. So we have a clash between accuracy, working with land use data, and the level of detail. The better the detail as seen in the OSM doesn't necessarily mean we have a high accuracy of the data set. But despite all this, we can clearly show that ecosystem services supply differs strongly between the different land use land cover types. And that is what we wanted to show at this point. Because this has implications for policymaking. Now, with this approach, we're able to show where which ecosystem services are supplied in a graphical manner. And that often helps us communicating the importance of ecosystems and the relevance of healthy ecosystems for livelihoods. Well, we've shown that urban areas are probably more diverse than the LULC data suggests. In this case, we've always have to keep in mind that working with land use land cover data reduces the complexity. And as the example of Saint-Laurent de Maroni shows, the better our data, the better the estimation of ecosystem service supply. And with this lens of multifunctionality that the ecosystem services concept allows us to take, we can show how important landscapes, intact ecosystems are. And that with the degradation of ecosystems, with deforestation activities going on, especially in the vicinity of urban areas, this highlights the need for balanced land use planning, as well, only through healthy ecosystems we can safeguard a steady supply of ecosystem services of, let's say, clearly of benefits for the urban and rural populations, such as buffering urban heat, buffering coastal supplying coastal protection through intact mangrove forest, or combating or buffering riverine or pluvial flooding events and inundations. And therefore, we need a balanced land use planning with intact ecosystems. And that already brings us to the summary. What we've tried to do with this case study was to provide a first assessment of current land uses and deforestation activities in French Guiana. And going along with that, presenting a first overview of ecosystem services bundles for the territory. And also give some implications for land use planning and the tool to communicate the importance of intact nature at this point. And if you're interested in our work, we would like to invite you to have a look at the case study booklet, Land Use Changes and Ecosystem Services in French Guiana. It will be out there shortly. And with this, I'm almost at the end of my presentation. I would like to thank again our partners in French Guiana, the CIRAD, but also the WWF French Guiana, Clément Villien, Laurent Kell from the ECOSEO project, and all our partners on site. And of course, the Université de Guyane for making our stay and our research in French Guiana possible. With this, I thank you very much for your attention.